Hi and welcome to Geeks for Geeks. Today we would be discussing the problem named as Geek and Knots. In this problem, we are given a wall A and a wall B, and A is provided with M hooks and B is provided with N hooks. And then we are also provided a rope. And what we need to do is we need to have this rope like this is the first rope, or we can have something like this to this. Okay, let me make it, yeah, or we can have something like this to this. Okay, so we are given the number of rows and we need to find the arrangement that we can do using these rows. Okay, so we are in the first given sample test case. We are given that A has 3 hooks and wall B has 2 hooks, and we are given 2 ropes here. Okay, so what I would do is I would take use of these 2 ropes. How I would just show you. Now, what I would do is I would take the first row and then I would link it to this one, and then I would link it to this one. This is how I would have 3 possible combination, and 2 combination are said to be different when they have different elements. Okay, they have different elements that is involved. Okay, like suppose if we have a knot from, I would just show you. So suppose this is hook 1. Suppose this is A1, A2, A3, and this is B1 and B2. Suppose we tie a knot from A1 to B1, and next we tie a knot from A2 and B2. This thing that we have done, and this is not different from A1 with a knot to B2 and A2 with a knot to B1. These two arrangement are not different. Okay, so these two be arrangements are told to be one. Okay, this is the problem statement. Now to solve this problem, we know that each time we are given a wall A, and each time for each rope we need to select how many hooks. We need to select k hooks from each of the M wall. So from M, we need to select k hooks. Okay, so we can say that each time we need to select from M, we select k hooks, and for each value, suppose we select the values 1 and 2. So for each one, we also select from N, we select again k hooks, because whatever the value of M or N, we need to select k hooks. Otherwise, less than that hook won't be happening. So, and we are also given that the number of hooks is less than minimum of M cross N. Okay, less than equal to. So this is also solved. We don't need to handle the case where the number of rope is greater than the number of MRM, because we need to use exactly k hooks. Okay, that is why this won't happen that from M we would first select 1 hook, then second hook, then 3 hook. Okay, we can't do that. Okay, we need to use k ropes at all times. Use k ropes at all times. So if we are talking about selection of M, choose K. This is what we are talking about. What I am talking about, I would tell you. So we are talking about combination. Okay, what is combination? The definition of combination is way of selecting items such that the order does not matter. So if the ordering does not matter, that means two two entities with different orders would be the same one. Okay, two entities with the different, like AB and BA, would be treated as one itself by this example. And this definition sets perfectly with what is being asked. Okay, so if the definition is setting perfectly with what is being asked, we would move forward to the calculation of NCR. Now what is NCR? NCR is n permutation divided by r permutation multiplied by n minus r permutation. This is what you need to do. So moving forward, let us first talk about a thing known as Pascal's triangle. So in a Pascal's triangle, it is made up of something like this, that the corner elements is 1, the corner elements are 1, and rest all element would be the sum of this and this. This element is a sum of this and this. This element is a sum of this and this. This element is a sum of this and this. This element is a sum of this and this. This element is a sum of this and this. That is 4 is the element of this. Now, if you observe, this is a general fact that Pascal's triangle, what it generally represents is, this represent 0, C, 0. This represent 1, C, 0. This represent 1, C, 1. This represent 2, C, 0. This represent 2, C, 1. This represent 2, C, 2. In the same way, this represent 3, C, 0, 3, C, 1, 3, C, 2, 3, C, 3. And then this represent 4, C, 0, 4, C, 1, and 4, C, 2. And then this represent 4, C, 3, and this represent 4, C, 4. Now let's take an abrupt value to see if this is really working or not. Let's take this value like 6. So to calculate the value of 4, C2, we need to have this is equal to n, this is equal to r. So the formula of NCR is equals to n factorial divided by r factorial into n minus r factorial. So just to be confirmed, this is n factorial, r factorial, n minus r factorial. So what we do is 4 factorial divided by r factorial, that is 2 factorial, divided by 4 minus 2, that is 2 factorial again, which is equals to 2 into 3 into 4. This would be just 2, this would be just 2. So this. So the value is coming out to be 3 multiplied by 2, that is 6. And yes, this value is getting confirmed. So you can do a dry run for all the values that are given and you would come to the conclusion that yes, these all values are correct. Now, to say you how I am writing this 20C00 C1, if you just write it in this manner, that 1 in this, just instead of this triangle, try to have this stacked up on the left hand side. So if you stack it up, this would be 1, 2, 1. This would be 1, 3, 3, 1. This would be 1, 4, 6, 4, and 1. Now if you draw the matrix, so this would be like this, this would be like this, this would be like this, this would be like this. So if you draw a matrix, then obviously this would be 0, 0. This would be 1, 0. Okay, I would be writing in it. This would be 1, 1. This would be 2, 0. This would be 2, 2. This would be 0, 2, 1. This would be 2, 2. This would be 3, 0. This would be 3, 1. This would be 3, 2. And this would be 3, 3. This is how you can easily say that which number is corresponding to which one. Okay, by visualizing. Okay, suppose you are telling them manually. So you can just tell him that. So to find out the value of this, what we can say is that if the first and the last value would be equal to 1. Okay, so if r is equals to 0, we would have the value 1. So if r is equals to 0, we would have the value 1. Okay, if n is equal to r, we would also have 1. So we can write a recurrence formula. So to find out the value of NCR, we can have a recurrence formula that if r is equals to 0 or n is equals to r, then we would return the value 1. Else all other values is nothing but 2C0. This is 2C0. Okay, so see this one. So this value is a sum of upper two values. So what is the upper value? So what is the difference between that? So if you observe this, so let me show you also. Okay, so let me enlarge this. So see, 1C0 and 1C1. If you add up these two values, then you would get 2C. Okay, 2C1. So how from 2C1, how can I get the values of these two? So I can simply say that n minus 1 and C of r minus 1. And here I would say n minus, this would be 1C1. See, this is 1C1. So let me write this also. So suppose we want to find the value of 2C2. Okay, we want to find the values of 2C1. Now suppose we want to find the value of this. So 2C1. So to have the value of 2C1, we need the value of this and this. So we would have 1C0 plus 1C1. So basically if we write 2 in the form of n and 1 in the form of r, because this is NCR, so this would be 1 would be, so 2 with 1. So 1 can be written as n minus 1 and 0 can be written as r minus 1. And then this one is 2 and this one is 1. So we can write n minus 1 and r is the same. So we can have this. So we can have this recurrence formula that if r is equals to 0 and n is equals to r, we would return a 1. Else in all other scenarios, we would have the addition of n minus 1 c of r minus 1 plus n minus 1 and c of r. So now this is the recurrence one that we can build up. Okay, so we can simply have like this. Okay, so to take out the value of, we would simply have void of. So to take out the values, what we can do is, now to take out the values, what we can do is we can simply have NCR. Okay, NCR of int n and int r. So we can say that if n is equals to, if r is equals to 0, or n is equals to r, we would return 1 in that scenario. Okay, where it is written? It is written at this point. If r is equals to 0 or n is equals to r, we would return 1. Okay, so now let's see the other condition. In all other condition, we would return the value of n minus 1 and r, and n minus 1 and c of r minus 1. So in all other condition, we would return ncr of n minus 1 comma r minus 1 added with the value of ncr of what? Let's quickly go back, of n minus 1 and r, of n minus 1 and r itself. So we would simply have this. Okay, so now we can memorize this also. Like what we can do is we can look at the, so we can look for what is the range of n and r, and we can simply memorize it. But we need to do the modulo also. So to do the modulo, what we would do is we would start filling up the DP array. So DP array of NCR. Okay, so to calculate the value of NCR, what we can do is we can fill up this. So we would use the same condition. As we are using the same condition, so I would explain you when I would start coding. Now let us move to the implementation. So as we need to do the modulo again and again, so what we would do is we would simply have int variable, int declared here only, int mod is equals to 1e9 plus 7. Okay, this is what is given. We need to do it, the modulo one. Okay, so now we would come down, we would say that long of dp of max of m comma n, because we need the maximum of ncr. Okay, so we would calculate till the maximum value so that we don't fall stop. Okay, like ncr or mcr, we ask and then we are not able to have that because that value is not calculated. So we would calculate the larger value. Suppose it might be the scenario that I can ask any values. So like this only. Okay, so suppose it is told that I can ask any values from 3 to 5. So it's better that I would have all the value calculated till 5. That is what I am doing. I am calculating till the maximum value of that. and we would do the same, that maximum of m cross n, and then we would simply add 1 to it. And then what we would do is we would again use a int I is equals to 0, I is less than equal to max of m comma n, and then we would simply do I plus plus. Okay, then what we would do is dp of I of 0 is equals to dp of I and I, okay, is equals to 1. This means that if this represents n and this represents r, so if r is equals to 0 or n is equals to r, we would have the value as 1. This is where we are writing this condition, okay, and then we would be moving to the value of r. So int j is equals to 1, okay, and j is less than equal to I, and then j plus plus, because the j of 0 is already calculated. So j of 0 is already calculated, so we know that dp of I comma j is equals to dp of I minus 1 and j minus 1, okay, and then add of dp of I minus 1 and then j itself. Now we need the modulo. So let us go a little bit about modulo also. So how would we calculate the modulo? So to calculate the modulo, suppose we want to have a plus b modulo m. So we need this. We need to have this. This value can go outside the range of integer. So we need the modulo of this. So if we want a plus b whole modulo m, this is nothing but a modulo m plus b modulo m, then whole modulo m. We do this. So we would do the same thing like a modulo mod, okay, then b modulo mod, and then whole modulo mod, okay, and then this bracket would close, okay, and we would compute the value of answer itself. So we would write in answer because we need to return an integer and we have initialized the long dp in the form of long. So we would say that dp of n cross k multiplied by dp of m choose k. So we know that the answer would be the multiplication of n choose k and m choose k. How it would be? Like suppose we are told, so suppose we are 1 2 3 4 and here we are told 1 2. So if we have 4 options and we have 2 options, and this is the total number of options would be 4 multiplied by 2. So that is why we would have this value. So now this value can also go beyond integer. So if we want to have modulo, that is a multiplied by b modulo m, this is nothing but a modulo m plus b modulo m and then whole modulo m itself. Okay, this is the same one, modulo mod modulo modulo mod and then whole modulo mod itself. Now to just compile and see how many errors are we making. So we need to have this capital in the uppercase. This is coming correct for the sample test case. Now let us submit this. And yes, we are able to solve successfully. Now there is one more way to solve the value of NCR. So I will just go in briefly because it has many prerequisites. The prerequisites are binary exponentiation. Okay. The prerequisite is binary exponentiation. The next prerequisite is Fermat's little theorem, and then modulo inverse, and then modulo arithmetic. So if you have all these prerequisites covered, then I would simply show you how this is calculated. So NCR is equals to n factorial divided by r factorial into n minus r factorial. So what we can do is we can pre-compute the values of n factorial and we can keep it in an array. And then we can pre-compute the value of r, keep it in an array, pre-compute the value of f, pre-compute the value of all the factorials. Then as we know that we need to have this divided by this modulo m something. So if that is prime, we would use Fermat's little theorem, that is this value to the power p minus 2, and we would have that. So consider learning that as a bonus if you want to level up. That's it for today. Thank you and have a nice day. If you face any difficulties regarding the understanding of this code or explanation, feel free to raise your doubts in the comment section. And if there is any scope of improvement, please let me know. And if you want a dedicated video involving these all explanation of these all prerequisite and then discussion of NCR using this thing, please let me know in the comment section. Thank you.